morning, everyone. We are going to be present about our project FEMAURA, an approach on polycystic ovarian syndrome detection using deep learning. Our project guide, Mistress Naina K, and head of the department, Dr. Shivangouda GM, and our project mates, Kavana M, Kushi Gujarian, Mamta CH, and Manjula KS. All you need to know about PCOS, this is an FEMAURA polycystic ovarian syndromes detection. In this session, we will going to be learn about introductions, problem statement, solutions, objectives, methodology, CNN architecture, conclusion. Coming to the introduction slides, polycystic ovarian syndromes is an hormone disorder that affects every woman of reproductive age. This is a common problem in every woman that the PCOS is an hormone disorder affects. So women with PCOS have difficultly become pregnant and may high level of androgen hormones from the ovary and androgen glands. So this is a common difficulty all over the world. Women can facing this problem about pregnancy and high level of androgen hormones and over the and adrenal glands. The organ systems that can be affected by PCOS include the brain, pancreas, liver, and etc. So this is the PCOS problem that can be mainly affecting the brain, pancreas, livers, etc. Most patients of the PCOS are women of reproductive age experiencing weight gain, irregular menstruational cycles, at times infertility, and many more. So, PCOS is a common in every woman's that can be more affecting in weight gain, irregular periods, monthly irregular periods, and infertility of every woman, and many more.
The problem statement is a distinctive machine learning framework for detection of polycystic ovarian syndrome to detect complex endocrine disorder that affects women in their reproductive years, which means our project aims to build a machine learning framework for detecting PCOS. So we have built a solution for that problem. In this project, we are developing a deep learning model to classify PCOS based on gathering information about women's health like hormone levels and medical history. It is designed especially for a woman who is suffering from PCOS, which causes missed or irregular menstruation, excess hair growth, acne, infertility, and weight gain. This proposed model diagnoses the PCOS morphology with ovary ultrasound images using deep learning which aims to reduce the false positive rate and increase the performance of the model. This reduces the false positives, improves the accuracy of PCOS, helps doctors in better decision making.
Objectives: to develop a deep learning module to detect the PCOS from the ultrasound images and to evaluate and validate the model performance on unseen data and to present the results and suggest the improvement for the real world use. Methodology: in this first step, the ultrasound image of ovary. In this process, the begins with the medical ultrasound images of the ovary. These images are used because the PCOS can often be identified by the multiple cysts in the ovary. And the second step, pre-processing. In this step, the pre-processing removes like a noise, low contrast or unclear images. This step improves the image quality of the image quality for the further analysis. And the third step, segmentation. In this step, segmentation helps identifying the boundaries of the ovary of the cysts and the ovarian structures. It ensures that the only useful part of the image is considered for the further verifications. And the feature extraction, in this step there are some features like size and shape of the ovary, the number of cysts, texture patterns and distribution of follicles. These features are the critical for distinguishing the PCOS affected by the ovaries from the normal ones. And the last is detected or not detected. Using the extracted features, a classification systems decides the whether the images is PCOS or non-PCOS. If the cyst patterns or the meet diagnostic criteria, the PCOS is marked as a detected, otherwise it is a not detected.
In our project, we are using convolutional neural network architecture. A convolutional neural network is a type of deep learning algorithm designed to work with images and able to differentiate one from another. In our project, we use CNN as backbone of our project to detect PCOS from ultrasound images with accuracy and speed. There are mainly three important layers in CNN architecture. One is convolutional layer, second is pooling layer, and third one is fully connected layer. Convolutional First one is convolutional layer. This is the first layer in CNN architecture. It takes the image as input and begin to process. There are three important elements in convolutional layer: input image, filter, and feature map. In this layer, it has filter element which help to capture import features like shape, cyst patterns, and texture. The second layer is pooling layer. This layer reduces the size of an image but keeps the important features. This makes the model faster and use less memory. This helps the CNN focuses only on important areas like cyst patterns. The third layer is fully connected layer. This takes all the extracted features and flattens them into a single vector. This works like connecting all neurons in the brain, helps the model learn complex patterns from the image. The last layer is output layer. Finally, the model gives the result PCOS detected or not. So, in simple words, CNN acts like eyes and brain in our system, for seeing, then understanding, and finally deciding. That is why CNN architecture is most suitable choice for PCOS detection.
Conclusion: the present work in our project in the domain of PCOS is to detect the PCOS incorporated the advantages of both conventional and technique and deep learning methods. This can be significantly beneficial towards both patient and health providers in identifying PCOS quickly and efficiently. An efficient machine learning approach to detect PCOS using ultrasound images is considered to be potential value for thousands of women's reproductive health. Thank you. And here it is the demo. Here our project, we find the PCOS detection by using ultrasound images. Here we choose the file. Here we insert the ultrasound images of the non-PCOS patient. So it detect whether it is a PCOS or non-PCOS. In this, it detect that the ultrasound images in it is non-PCOS. Now we upload the ultrasound images of the PCOS patient, so it detect that the person has a PCOS. Thank you.